to switch things up, but since that didn't take as long as I thought, we're going to go straight with the schedule. Hey, this is 3 more days, guys. We can do it. We're almost there. Hallelujah. Okay. So we are on 12.4. We want to be able to find areas of sectors. And we're also going to talk about surface area a little bit today, which isn't too bad usually. We know how to find areas of things. So we want to start by finding the area of the sector of the circle. And we've done something very similar to this before. We might just want to find the area of a shaded region of the circle. And again, what we want to do is sort of create a proportion, relating some things that are equivalent that we have here. So we have circle O, and it says OP is 10. What is that information telling us when they tell me OP is 10? The radius is 10. All right, and then the measure of angle POQ is 72 degrees. Thank you. Okay. And we want to go ahead and find the area of that shaded sector, that portion of a circle. So just like before, we want to find an area of a sector. Well, it's just a small part of the total area of the circle. What is the formula for the area of a circle?
Area equals pi radius squared.
Pi radius squared. Very good. And then they gave us degrees. So again, we have a certain number of degrees out of how many total degrees in the circle? 360 degrees. So this is sort of how we go about setting up these sort of areas of circles. And again, we've done this before with arc lengths, like the lengths of the arcs of circles. All right, we're trying to figure out the area of the sector. And we know the radius is 10, so we're going to do pi times 10 squared. And what is our central angle measure here? 72 degrees out of 360 degrees. And all we need to do is get area of a sector all by itself. So what should I do here? Cross multiply. Yeah. We're going to take this denominator and multiply it to the other side to get rid of it. And so that way the area of the sector is all alone, and we have 72 times pi times 10 squared over that 360 degrees. And there's lots of things you can do in your calculator there to get that answer, but 72 times pi times 10 squared divided by 360 is one way that works just fine. And so we get 62.8. Oh, crap. I didn't read the directions. Oh. I didn't read the directions, which say fraction of pi, a fraction of pi. So, yeah, so that means that we want to have pi in our answer, but I'm just going to worry about the numbers then. So we're going to do 72 times 10 squared and divided by 360. That's going to take care of the numbers. So that would give us 20 times pi for the area of the sector in terms of pi, which I should have read. The hardest part about math is reading. How many times have I said that this year? Okay, a lot. Okay, let's try B. Let's see, it says LM is 9. Again, that's a radius for us. And the measure of angle MLN is 160 degrees, and we want to find the area of that shaded region. And we need to express our answer in terms of pi. So I want to find the area of my sector over, what is our total area? What area? Pi times 9 squared, pi radius squared equals, what's our angle measure? 160 degrees out of the total 360 degrees. And then what do we need to do? Yeah, cross multiply that stuff to the other side. So the area of this sector, we're just going to do 160 times pi times 9 squared divided by 360. And all I need to do then is just put all the numbers in my calculator, leaving the pi to attach later. So my calculator, I'm going to do 160 times 9 squared divided by 360, and I get 36 pies. Okay, questions on either of those two? So again, this setup is really how we start all of these things. We've got two more that are slight variations on that. So in circle L, LM is 6. So again, they're giving us the radius there. We want, and the area of the shaded sector is 10 pi. So I know that this area of that shaded piece is 10 pi. And we're trying to find the angle MLN. So this, we don't know. That's X. We're trying to find X. So I'm going to set this up with the same sort of proportion setup, which is the area of my sector over total area. What is the total area of the circle? Pi times squared. Pi radius squared, yeah? Okay. So part of the area over the whole area equals, do I know how many degrees this angle is? X. 360, yeah. So now our unknown is over here on the right-hand side. What do we need to get rid of?
The 360.
The 360. So yes, we're going to multiply that 360 to the numerator over there. So let's see. I'm going to do 360 times 10 times pi on top. And on the bottom, I'm going to go ahead and do 36 pi. Did I do anything special there? No. I'm showing you this because I think it is important that you learn how to simplify some stuff here. What happens with these pies on top and bottom? Yeah, that's always nice. And then how many times does 36 go into 360? 10 times. And so 10 times 36 is 360. So we're left with 10 times 10, which is simply 100 degrees equals X. Could you have put that stuff in your calculator if you needed to?
Yeah.
Sure, absolutely. Okay. All right. Here in letter D, we have the measured angle HGI is 45 degrees, so they are giving me my little angle, central angle measure. And the area of the shaded sector is 1/2 pi, so they're telling me that shaded sector as well. And we want to find the length of GH. What is the length of GH? What are they telling us to figure out? Yeah, so we're trying to figure out R in, find R in this case. So let's set it up just like we have been doing. So I want area of the sector. What's the area of our sector?
1/2 pi.
1/2 pi. Over the total area of the circle. What's the formula for the total area?
Pi r squared.
Pi radius squared. Very good. And the R is what we're trying to figure out here, so that's good. And then we want our angle, our central angle measure, 45 out of 360 degrees. So part of the circle out of the total degrees of the circle. All right. Now, how do you suppose we're going to solve this? Cross multiply. This one, we're going to cross multiply because what we're trying to figure out is in the denominator, and that's no bueno. We have to move it. Totally. So we're going to have 360 times 1/2 pi. And on the other side, we have 45 times pi times radius squared. I'm going to clean this up a little. What's half of 360? 180. So we have 180 pi equals 45 pi times radius squared. How should we solve? Divide by 45 pi. I like the sound of that. Divide by 45 pi. All right, the pi's and the 45's cancel out on the right-hand side. Pi's cancel out on the left. And what's 180 divided by 45? 4. Very good. Equals radius squared. And then we need to square root both sides. Very good. So we get a radius equal to 2. Beautiful. So again, the setup is really nice because it allows us to solve for every possible thing they could ask for. So keep that in mind. Okay, questions on any of those? All right, so now we're going to talk about surface area. So this is really kind of interesting. I'm going to write down at the end, we'll write down the formula. We want to figure out the surface area of a cone, and surface area is like the wrapping paper. If you're trying to wrap up your cone, we want to know how much wrapping paper that we're going to use. So here you see I have my cone, and I've wrapped my little cone in paper, a little paper hat. And of course, surface area is all the surfaces. So we have this bottom surface as well that also has some wrapping paper for it too. So surface area means we want to find how much space all of this wrapping paper takes up. Now, we can unfold it, and what I've done here is this is the net for the surface area of a cone. And so first we have that circular base. We know how to find the area of this base already. What's the formula for area of a circular base? Yeah, so this circle, we know that the area is pi times radius squared. Okay, so we already know that one. But then we have the cone. This is called the lateral surface. Lateral just means side. So this is sort of the side of the figure, if you will, but it's round, so that's kind of a weird thing. But so if I unwrap this, you can see that our surface area turns out to be this sort of pie-shaped sector, and it turns out that this is essentially a sector of a much larger circle. So you can imagine, like, here's this big circle, and we have a sector. And so we're going to figure out how does sector area relate to the surface area of cones. And I have to say, this is something that when I was in school, they just gave us the formula, which you're welcome to just use the formula, but I'm going to show you today where it comes from. But you can see we have this sector area. This is what we just did. And it's part of a larger circle. So what we want to do to figure out the lateral surface area, which is this portion right here, we're going to basically do what we were just learning. So when I look at this lateral surface, this little sector, I am trying to figure out this sector area. And let's see, so I want to find this area of a sector, all right, this sort of shaded area. And that's what we were just doing. The area of this sector is what we're trying to find. And this is a portion of this much larger circle. Well, this much larger circle, you can see, has this radius S. What is S?
The radius of the base.
Is it the radius of the base?
No.
No.
The height of the...
Is it the height?
No.
No, it's this. What is that?
The hypotenuse.
It's like a hypotenuse. Yeah, this is the slant height. Slant height of our cone. And you can see that on the shape here. Like, here's my cone in its wrapping paper bandage. And we need to know this height called the slant height. So it's sort of on the side, and it's the slant height of our cone. And that actually becomes the radius of this big circle, which is kind of interesting. So the total area of this large circle would be pi times s squared, because that radius is a big radius. I'll just think about this as the big radius right there, s. Okay. And then I don't have any degree measures, but I have one more thing in this, which is kind of interesting. Normally, we were doing degrees out of total degrees, 360, but I don't have any degrees. So I'm going to use a different measurement that I do have. And that is that I have this, let me see, right here, this edge of my sector right here. Where does it touch? What does it wrap around? Yeah, it wraps around the circular base. Do you see that? So, like, our wrapping, like, actually touches the circular base all the way around. And so this edge right here is actually the circumference of our little circle, because it's sort of wrapping around. And so this, what we're going to have, the arc length. This length is equal to the circumference of this circular base. That's going to be 2 times pi times r. That's kind of interesting. That length, 2 times pi times r, is the same. It is a portion of the total arc length of the big circle. So the total circumference all the way around the big circle, well, that is 2 pi and the radius of the big circle, which is s. So 2 pi s. This is really kind of interesting. All right, we're going to clean this up, and it turns out that it cleans up real nice. So what we just did is a little sector, a little section of arc length out of the total arc length, the total distance around the big circle. We are going to multiply this over here to the numerator, and it turns out, after we clean it up, let's see, 2 times pi times r times another pi times side squared, all over 2 times pi times the slant height. Sorry, not side, but slant height. Let's see how this cleans up. I get some pi's that cancel out. I get some 2's that are going to cancel out. What happens with s squared divided by s? It just gives s to the first power. Yeah, the s and one of those is going to cancel out. So we just get a single s left over. And so it turns out that the area of that sector is just left with pi r s. So this surface area, this lateral surface area, is simply pi times the base radius times the slant height. Isn't that kind of amazing how it cleaned up like that? I think it's phenomenal. So here we go. Altogether, the surface area for a cone is the area of the circular base, which is just pi r squared, plus this area of a sector, which turns out to be pi times radius times slant height. So this is the formula we get to use to find the surface area of a cone. The nice thing is you never have to do this again. You never have to think about that. But it is nice to know. It's not that hard to get, but it's kind of interesting. All of this just for this nice little formula. So the area of the base plus pi times radius times slant height. That's crazy. Here we go. Let's try it out here. Find the surface area of the cone. So the surface area, I'm going to use my formula. Pi r squared, that's the area of the base, plus pi times radius times slant height, pi rs. And all we have to do is plug in the numbers. What are we going to plug in for the radius of our cone? 4. So pi times 4 squared plus pi times, what's my radius? 4. What's my slant height? 6. Yes. I wonder how they want this. Let's do this one in terms of pi. 4 squared is 16 pies. And then here we have 4 times 6 is 24 pies, which is how many pies in all? 40 pies. Ooh, baby. That sounds like a good old... All right. It's a whole lot of food is what it is. All right, so 40 pi, great answer. You could approximate it if you want. Letter B here. What's the radius? It doesn't give one. Exactly. So what is the radius? 5.5. Very good. It'd be half of 11. And they still gave us our slant height, so that's good. So then if I want to do the slant height, we're going to do pi r squared plus pi r s. S for slant height. And so plugging in my numbers, I've got pi times 5.5 squared plus pi times 5.5 times 7.2 for my slant height. And because this gave us decimals, I am just going to go ahead and use my calculator and plug everything in. Pi times 5.5 times 7.2. And again, all the calculator, pretty easy, 219.44. Again, pay attention to how many decimal places they want you to round to. Make sure you read that sort of thing. This is centimeters squared because we are talking about area. Area always has square units. All right. Any questions on these two? Formulas are easy, right? What's missing on C? What do we need to figure out? Slant height. We do need to figure out the slant height S. And how are we going to figure out the slant height? A squared plus B squared equals C squared. Very good. So 10 squared plus 13 squared equals my slant height squared, or my hypotenuse squared. What is that? 269, I guess, is equal to slant height squared. And how do we get the S by itself? Square root, which I'm going to do in my calculator. So the square root of 269, something like that. Yes, 16.401. And again, we do not want to round things off. So I'm going to keep my decimal in my calculator for easy access. And then I need to find my surface area, which is pi r squared plus pi r s. I really encourage you to write it down until you have it memorized. That we can go ahead. And pi, our radius is 10. Very good. Pi times 10 squared plus pi times 10 times the 16.401 craziness. Pi times 10 squared plus pi times 10 times my answer. So again, I'm using the second answer button at the bottom to pull in that decimal from above. And we get 829 point, let's go 42. What are the units on that? Millimeters squared. Very good, because it is area, so we have square units. Let me ask you a question. I don't want to do this one right now, but I do have a question. What if you needed to find the area? Woo! Yeah, let me just throw that right at you there, Tyler. Sorry. All right. How do you find the surface area of a pyramid like this? What do you need to do? How do you find the surface area of this figure?
Like just do it 3 times.
Add up all the sides. Absolutely. So we have the base, so we'd have one of those, and then I have 1, 2, 3, and 4. Yeah, 4 congruent triangles. And so if you have your, what would be that that central height here of this triangle. You have your base and your height, 1/2 base times height, and we need 4 of them, okay? So, finding the surface area of a pyramid is much easier than these rounded ones, okay? These are much easier. Do you have questions for me? Okay, fantastic.
Everything, did you get it done?